All right, so here's a quick introduction to signal detection theory. As I demonstrated in the backward masking demonstration, in typical consciousness research, we present some stimulus in the visual domain or auditory domain, and then you have two different kind of situation, which is stimulus present or stimulus absent. And then, as a subject, you will respond that, oh, I saw it, or no, I didn't see it. Let's say, you first categorize this response into two categories. And then signal detection theory first names these two types of the categories of the response under the stimulus present condition. Okay, and when the stimulus is present and then subject said that, oh, I saw it, you call it as a hit. And if it's not, then miss. The stimulus was missed. And then when the stimulus was absent, but subject said that, oh, I saw it, it is called a false alarm. And then when it's correctly rejected, as it says correct rejection. So these are the four types of the categories of the trials that signal detection theory requires you to assign for each trial type and a stimulus type and the response type. And then a potential model of how the mind works or conscious mind works in some sense. Here's the signal detection model. X-axis of this figure corresponds to the strength of your internal response or the visibility or the qualia or whatever, the strength of something that is visible to you. Okay, and then the y-axis is the likelihood or probability that you estimate subjectively. Okay, so this means that this particular vertical bar is your criterion of your response. And if the under the stimulus present condition, let's suppose that the probability that that stimulus evokes the strength of this particular strength of the qualia corresponds to this level of the probability. And then suppose that you have a model that as a function of the stimulus strength, your response increases, and also your response distribution looks like this normal distribution or Gaussian distribution. And then if you say yes only when you think that the internal response exceeds certain criterion, then that corresponds to the hit trial. You are saying yes to stimulus present trial. And if you're saying no, then that corresponds to miss. And then when the stimulus is not present, absent here, and then let's say you have this type of a distribution on the shifted to the left. And then you say no if it's below and say yes if it's above. And then here you obtain this correct rejection and false alarm. So this is a one particular model of your conscious detection. And then now signal detection theory introduces the probability of hits and false alarm depending on the level of the criterion. So if the criterion is shifted to the left, then you are most likely to say yes all the time, right? And then you are almost always correct in terms of hits, but also you make a lot of mistake in terms of false alarm here, this side of the mistake. And then this enigmatic symbol d prime equal 1 corresponds to the separation of these two Gaussian distribution, in the unit of 1 standard deviation. And then now, if your criterion is shifted to the right, then you are likely to say yes much less, and then accordingly hits and the false alarm decreases. And then further to the right of your criterion, now you become more and more conservative. And then the conservative person would say that yes, much lower probability, and then say you get the hits 50% and the false alarm 16%. And then the interesting thing about signal detection theory is to suggest that you plot hits and false alarm by shifting the criterion all the way from the left to the right to draw a probability of the hits and the false alarm on one graph, such as this. So this is what I said, receiver operating characteristic curve. And this allows you to separate criterion from distinguishability or sensitivity. And how it works. So if you go from the left, that corresponds to the top right part of the ROC curves, or receiver operating characteristic. What it means is that if your criterion is really left, then you're likely to say, yes all the time. And the yes all the time corresponds to hit all the time and also false alarm all the time. And then this particular case, 97% and the false alarm 84% corresponds to this red dot. Similarly, this the higher criterion corresponds to the green dots here and blue dots here as the criterion goes to the right. And then notice that these three dots are aligning on one particular curve. And this one particular curve is called the D prime of one curve. And along this line, your percentage of hit and the false alarm changes. However, D prime sensitivity does not change. And sensitivity or discriminability of the D prime is now separated from the criterion. This is a highly lenient criterion. This is most more conservative criterion, and the most conservative criterion you say no all the time. And notice that this is a potential problem of the consciousness when you are asking people to say yes I saw it or no I didn't see. If you do not shift the criterion, then you will never know whether it is a problem of criterion or sensitivity. And as you go from this low sensitivity D prime to zero sensitivity, meaning that two response is completely overlapping, D prime equals 0, and then D prime 0 corresponds to the diagonal on the ROC curve. And this is sometimes used called as a chance performance in the terminology of the consciousness research. And then as the separation of the two situation, visible and invisible, becomes highly distinctive, you will see something like a D prime equal 3 situation where not much overlap is happening, and that result in this D prime 3 curve on here. And then sometimes ROC curves, area under the curve is quantified, and the area under the curve is sometimes called A prime or AUC, and that corresponds to D prime equals 0 of A prime or area under the curve of 0.5, half of this area corresponds to 0 D prime equals 0, and the perfect performance of the AUC is 1, complete full area under this curve. So in practice, how we can estimate ROC is a little bit convoluted. But the most straightforward way to do it is to try to do this experiment many times and ask people by changing their criterion, either implicitly by giving more reward or more punishment in saying yes or no, or then making a mistake or making a correct hit. For example, if you give $100 for the correct hit, whereas you give only $1 for the correct rejection, then people are likely to say yes. Okay, but if you do the vice versa, people are likely to say no, and without changing the sensitivity. Another possibility is to change the instruction. Just directly ask them to provide a yes or no roughly equal proportion, or say yes more likely than or no. And also another possibility is to manipulate the probability of the stimulus present versus absent. People usually are very good at detecting the probability of the stimulus. So if stimulus is present all the time, then people are automatically adjusting their criterion to say yes more frequently, and no more frequently when you manipulate the probability of the stimulus much lower. And this relates to the problem of the expectation in the consciousness research. If you're set up the situation where you do not expect any kind of stimulus to arise, then people are also likely to say no. And this relates to the problem of inattentional blindness. Okay, and then finally, you can also combine this confidence rating with manipulation of the rate of the criterion. But this one is more analytically a bit complicated, so I will leave it for now. Potentially, a couple of weeks from now, I'll discuss about this method. Okay. So just to give you a little bit more hint about ROC analysis or standard signal detection theory, there are a couple of YouTube video link. I made a link I provided here. So if you're interested, please watch these videos. So to summarize this part of the lecture, I introduced that conscious phenomenology is most directly accessible to the introspection. However, introspection is just a good starting point, but not really enough for consciousness research. So translating phenomenology to report is a challenging but very important step in the consciousness research. And the way to do this is analytically and so methodologically making progress all the time. And I introduced one of the fundamental method called the signal detection theory as a powerful framework to objectively quantify and separate discriminability and criterion. And this can be used as a sort of the guiding principle for your, and also, when you analyze or when you read the paper about the phenomenological reports, then you can consider these aspects of the paper. And we'll go to the neuronal measure in the next video.